Hi dear friends, today I have a question written before you. The question says that two different non-parallel lines meet the circle mode of z is equal to r in the points A, B and C, D respectively. If these two lines meet in z, then z will be given by. Okay, so I have drawn a rough diagram for understanding purpose. As you are seeing that there are two lines and these two lines are non-parallel and the circle is given as mode of z is equal to r and the points are given to us. This is from the topic of complex numbers. So let us start solving this question. Now ABCD, all the points ABCD lies on circle. Therefore one thing is very clear to us, one thing should be very clear to us, and that is mode of A is equal to mode of B is equal to mode of C is equal to mode of D, and that should be equal to R, right? Why? Because these all points lie on the circumference of circle. Now therefore we can say that A bar is equal to B bar is equal to C bar is equal to D bar, right? And that is equal to R square. Okay, see why I'm writing like this, because if A is x plus iy and you multiply it with its conjugate, that will be equal to x square plus y square, which is actually the square of its magnitude. So now what I can do from here, we are given that A, B and Z are collinear. Okay, they are collinear because they lie on the same straight line, right? There should be no doubt regarding this. A, B and Z lie on the same straight line, thereby they are collinear. Now I can write that from the property of collinearity, even if you have read vectors, you would be very much comfortable with this expression that I am writing. Z minus B is equal to lambda times of B minus A, right? I can write it. Now from here I can say that this implies that Z minus B by B minus A is purely real. What it is? It is purely real. Why? Because this is equal to lambda, right? This is equal to lambda, and therefore I can say that this is going to be purely real number. I'm actually increasing it a bit. Okay. So if it is purely real, then I can write it Z minus B by B minus A should be equal to mode of Z minus B upon B minus A, conjugate of. Okay, now if I'm writing this as conjugate of, then this bar will percolate to each and every member. That means I can write it like this: Z minus B by B minus A is equal to Z bar minus B bar upon B bar minus A bar. Okay, now once I'm able to write this, let me scroll it a bit. Once I'm able to write this, then from here what I can do is, it is very clear that we need to do what? We need to cross multiply. Now if I cross multiply this, then I will get B bar minus a bar into z, okay, minus b minus a z bar, right? And plus what I did, I multiplied this z bar with this term and then I brought it to the left hand side. Now what is going to remain? Minus b into b bar minus a bar, and here minus b bar into b minus a bar, b minus a. So if you will simplify it, you will get nothing but a b bar minus a, sorry, I don't know why I'm not able to delete it. Yeah, it's deleted. So what I'm going to write here is a bar b minus a b bar, and that is equal to 0. From here I can write z bar is equal to b bar minus a bar into z plus ab bar minus a, sorry, a bar b, not ab bar, not ab bar, okay, a bar b minus ab bar and upon b minus a, b minus a. Okay, this is z bar. Similarly, on the similar lines, if I take um, if I take C, D and Z points, if I say that the points C, D and Z are collinear, okay, if I take this, sorry, I was trying to draw a line, but so I can write from here that C, D and Z are collinear, right? They are collinear. So on the same lines, as we discussed just now, I can write from here d bar minus c bar into z plus c bar d minus cd bar upon d minus c. Now see, both of them are actually representing the same thing, that is the conjugate of z. So from here I can say that both must be equal. So b bar minus a bar, b bar minus a bar into z plus a bar b minus ab bar upon b minus a should be equal to d bar minus c bar into z plus c bar d minus cd bar upon d minus c. Okay, so now what can I do? Now what we discussed initially, was z in a into a bar is equal to r square, b into b bar is equal to r square, like this. So in place of b bar, a bar, d bar, c bar, what I can write? See, in place of b bar, I can write r square upon b. Why? Because b bar was equal to r square. Similarly, a bar was equal to r square. What I am doing actually is, see, a bar is nothing but r square. So what I can write? A bar is nothing but r square upon a. Okay. So basically I will be doing this for all the terms. So from here I can say that b bar is equal to r square by b minus r square by a times of z plus r square times of a into r square times of a into b minus r square a by b, and upon, in the denominator there is b minus a, and here it is r square upon d minus r square upon c into z plus r square d upon c minus r square c upon d, r square c upon d. So what I did was that I got rid of all the conjugate terms. Okay, by doing this I got rid of all the conjugate terms. Now if I simplify further, then I will get minus z by ab plus b plus a by ab, and that is equal to minus z by cd plus d plus c by cd. Okay, if you will simplify it, you will get the following terms. How it will come? See, r square z upon b. Okay, r square z upon b. Here it is r square b upon a. Here it is r square a upon b, like that. Now if I see here z is common. Okay, here z is common. If I take the z components on one side, and if I take the another components on another side, then we will get these expression. Okay, because I don't want to go into the nitty-gritty details of doing calculations, hence I am avoiding it and directly writing the results. So z upon 1 by ab minus 1 upon cd is equal to b plus a by ab minus d plus c by cd by cd, and that is equal to what I can write from here. See, this is nothing but 1 by a plus 1 by b minus 1 by c minus 1 by d. So this can be written as a inverse plus b inverse minus c inverse minus d inverse, right? And from here I can write z is equal to, therefore z is equal to a inverse plus b inverse minus c inverse minus d inverse upon a inverse b inverse minus c inverse d inverse. So option B is correct option. Option B is correct. See, for simplifying all of these terms, you need to take a pen and paper, and you need to do yourself on the pen and paper. So this was a good question from complex numbers. I would advise seriously to once again do it on with pen and paper and solving on your own. You have got a layout, and then try yourself that how the calculations are getting done, how each and everything finally settles to the solution. So I hope you would have enjoyed the video. Thanks a lot.